This tutorial is for users wishing to code in Python using Jupyter Notebook on SAS Viya. Hi, I'm Charu, an instructor with SAS Institute. Here's a little background on me. You can also find me on blogs.sas.com. On the agenda today, we'll cover 3 topics. I'll first show you how to start a CAS session and connect to CAS, and then we'll use CASTable objects like a DataFrame. And finally, we'll explore data and gather summary statistics in Python. Programming in SAS or against one of the SAS engines is one of the most powerful and flexible ways to deliver results to SAS users. SAS has continued to evolve through time. From classic SAS Display Manager to GUI SAS Enterprise Guide to Thin Client SAS Studio, SAS continues to evolve to embrace open source integration with Python using Jupyter Notebooks. So let's get started with section 1. Let's get started with Jupyter Notebooks. I'll launch Google Chrome from my desktop, and then I'll hit the Jupyter Notebook tab. I already have a notebook that I've built before. I'll open it up. And when Jupyter Notebook launches, you'll see that it looks literally like a notebook, a running notebook. It will be useful to just examine our interface for a quick moment here. Up above, you have something called a markdown cell, and this is where you could have titles. Down below, you have cells where you can have code cells, and the code cells include both input, and as we submit code, we will also see output. The run button would be useful for us. We'll hit that every time we want to execute a piece of code. Some other things, Jupyter Notebook likes to put comments with a hash tag. So you want to put the hash sign before a piece of code, and when you execute it, it'll be considered as a comment. In section 1, we'll be starting a CAS session and connecting to CAS. And to do that, we have a couple of items that we need to take care of first. We'd like to first import the SWAT package. And the SWAT package is a Python interface to CAS. Before you use the SWAT package, you will need a running CAS server. So here, I'm going to just remove that comment and execute this code. I don't really expect to see any messages or any comments when I execute. Next, I'd like to create a CAS connection. In order to submit this connection syntax, I need a few things here. I need 4 things to be exact. I need the host name, that is server.demo.sas.com. I need a port number. In this case, it's 8777. I need a username, which is student, and a password that is metadata0. Here, I've typed in the code I need, and I'm using the SWAT package and connecting. We've already connected to a CAS server, and now we'll create the CAS connection by hitting run. At this moment again, no messages, no notes, not sure what's going on. So what I'd like to do is just get some help. And I can do this with CAS actions. CAS actions perform a single task. And to ask CAS directly for help, I'll use help action, just like so. Con.help. Con happens to be the connection we made to CAS, and within that, help is an action set. So if I punch in con.help and execute, I'll see a plethora of help available to me and a definition of each of the help actions. I'll scroll further down here, and I'm going to run a simple action called server status, because I still don't know if the connection is working. So con.server status is what I'll execute. I'll get a note about grid node action status report. And then in there, I'll get more information about the node status, the controller, the server status. At any one time, there is one CAS lib that is considered to be active. An active CAS lib means that any table references are assumed to be the active CAS lib. How do we find out what's active? We'll use an action called CASLib info to validate which CASLib is active. So once again, I'll remove the comment and I'll submit this code. I'll execute it. So I get some information about the libraries in my CAS session. CAS user is one of the libraries. There's formats. And when you see the column that says active, a 1 indicates that this is my active CASLib. A 0 indicates inactive. So now we have an active CAS session. We have imported a SWAT package to be able to write Python. Next step for us would be to load data. And we're going to load it from the client side. This would be the simplest way to load data. And loading data from the client side, just as a note, will be slower than loading data from the server. And client-side data loading is basically intended for smaller data sets. We have a method called read_CSV. It works just like the Pandas read_CSV function. In the following scenario down below here, I'm pointing to a URL reference. And by the way, all of the code, this Python notebook, the data that I've used for this tutorial is all going to be available on GitHub. And even the notes here, so perhaps you won't need me after that. So I'll remove the hash sign here and execute this code. And then we get a note saying CAS made the uploaded file available as, and then it gives kind of an odd looking name for the table. We should have the cars table in our SAS session. However, if you don't like this difficult to read generated table name, you can certainly specify one using the CAS out equals parameter. This one right here. And when we execute this, we might be happier with the identity of the cars table in CASLib. We can get quite a bit of information about our data using CAS actions and do some simple statistics, nothing major, just some basic stuff. And these actions are in an action set called simple. It should already be loaded. And we can verify this by running action set info. Scrolling down in the output, we see that the simple action set is already available and loaded for me. Something that might be easier in the IPython environment, in the notebook environment, and getting the help to content to pop up in a separate pane is to simply add a question mark after the action set attribute name. Just like this, con.simple, and then a question mark. And then we're going to get a little table open up down below. And within that table, you're going to get the type of the action set is simple. And within that, the kind of actions that I can execute. If, however, I'm going to X to close this off, you'd like to see the help for a single action set, you'll specify the action set name as a parameter. So I'll say con.help, and in brackets, action set equals simple. And these are the results for the simple action set. What we've mentioned earlier is these methods in the CAS object use Pandas functions under the hood, which means to our advantage, we can also use all of the Pandas parsing options. For example, I'm going to use cars.summary. So this gives me some descriptive statistics for my cars dataset. And for those of you who are familiar with SAS programming, you'll certainly remember it looks like a proc means or a proc summary in the results. Certainly, CAS comes with a few preloaded action sets. But it's likely that you might want to load action sets with other capacities, other capabilities like percentiles. You might want to do some data steps, SQL, or even machine learning work. The action used to load action sets is called load action set. So I'll go ahead and load the action set called percentile. And then once it's loaded, I can use this action set on the cars table. So I'll get percentile information on the cars table. Now that we made a connection to CAS and we've used some action sets, we've also imported the SWAT package, we'll move on to section 2. Here, we'll use CASTable objects like a data frame. The CASTable object is the most important object in the SWAT package, other than the CAS connection object that we used in section 1. It keeps our CASTable settings in one object. CASTable objects don't contain actual data. They're simply a client-side view of the data in a CAS table on a CAS server. Some definitions might be useful here. What is a data frame? What is a series? A data frame in Pandas is similar to a SAS dataset, a two-dimensional data source with labeled columns. And a series represents one column. So you want to think about a dataset being similar to a data frame. A single column in a dataset is like a series. Let's head over to the demonstration. Let's move on to section 2, where we'll use CASTable objects like a data frame. It might be helpful to look at a compare and contrast between CAS tables and data frames. So what is the difference between these two? The main difference between the two is location, location, location. A CAS table is of course in CAS, and a data frame is local. In addition, there are two other points about a data frame. Firstly, you can load data locally into data frame and alter it in Python before you decide to load into CAS. Also, secondly, it's typical to build models on the CAS server and then download the CAS tables to local data frames in order to do some data wrangling in an open source language. So what about CAS table objects? They don't contain actual data. They're simply a client-side view of the data on a CAS table on a CAS server. So the very first thing we'd like to do is to create a data table in CAS. And we'll begin first by loading iris.csv into a data frame. Now, data frames are not built into Python, so we must first import their definition from the Pandas module with this import statement. Once that's done, I can load data from iris.csv sitting in this location using the read_CSV method in Pandas. Subsequently, I can now interrogate this data frame by using a method called columns. The columns method returns for me all the columns in this data frame. I had been playing around a little bit with this iris table, so I'll go ahead and first give it a drop using the drop table method. So once it's dropped from my CAS user, I can go ahead and use the load table method to load this table into a CAS table. The definitive note indicates that Cloud Analytics Services made the file iris.csv available as iris in CAS user. Now, does the table exist? Does it really exist? We can go ahead and supply the table info method, which will return for me the information that this table is actually in my CAS user. Along with the iris table, I also see the cars table, which, if you recall, we had loaded in section 1. Further down, I'd like to do a little bit more analysis of this table, very basic reporting, such as give me the top 5 observations. The head method gives me by default the top 5. With the n=4 option, I can supply a restriction and request just 4 rows of data. There we go. We have the first 4 rows of data. A Pythonic thing that you're noticing here is observation number 1 begins at the 0. And that is different from SAS, where first observation is 1. Typically, we're trying to use CAS when we have large data sets. And so we might have hundreds of variables. We can actually subset the number of variables you're bringing in using the columns parameter, like so. The tail method gives me the bottom 5 rows of data. The columns parameter indicates here that I want to restrict the columns that appear in the result to sepal length and petal length. There we go. The bottom 5 rows of data for the 2 columns, sepal length and petal length. Now that we've loaded data into a data frame and we've also loaded into a CASTable, we'll like to do some compare and contrast. We'll first like to see the data types using the dtypes method. On the data frame, the types are float 64 for 4 columns and object with the species column. I can also see the same for my CASTable. You'll notice a small difference. The data types supported by data frames and those that are supported by CASTables in the result that we just see here have different names. The different names really don't matter since the Python float 64 is equivalent to the CASTable. The Python object type is equivalent to varchar in CAS. In this final section, we'll see how to explore data with histograms, analyze, visualize, manipulate, and also do some data cleansing. Now for some more visual fun stuff. We'll begin section 3, and in this section, we'll explore data and gather summary statistics. In our data exploration segment, we'll build a histogram. Histograms are able to help us view the distribution of numeric variables within a data set. And typically, we look to histograms to identify outliers. We'll use the Python hist method to create a histogram of all numeric variables. If you recall in the iris table, we had 4 numeric variables. So we are going to see the distribution for these 4 numeric variables. An option called fig size in the code specifies the size of the plot which you'd like to create. So I'll resubmit this code. And voila, some nice looking visuals for histograms for the 4 numeric variables. We'll do some more data work here. We'll move on to data analysis next. The describe method is a common method for a data frame to provide us some descriptive characteristics of the data. We'll get some basic summary statistics like mean, minimum, quartiles, etc. So I'll use the describe method, and then I'll submit dust, and this will give me descriptive statistics for the numeric variables in my table. So these are the results of the DESC method or the describe method on a data frame. Something we like to observe here is something that'll come in handy later. Sepal width has a maximum of 4.4 centimeters. So we'll just park that for a moment. We can continue, and out of curiosity, we like to see the type of this describe method. And it'll return for us that this is a data frame within Pandas. We'll do similar actions for our CASTable. We'll ask to describe the table and then submit CASTest. Similar looking result with descriptive statistics for the 4 numeric columns. Again, requesting the type will reveal that this is a SAS data frame within SWAT. One last thing, I submit TBL, and this returns to me the name of the table and its location, which is a CASLib of CAS user. Within the realm of data exploration, Percentiles are another useful tool for numeric data exploration. And by default, the percentile action that we'll use subsequently computes the 25th, the 50th, and the 75th percentiles for the selected columns. So I'm using the describe method, and within there, the percentile action, and supplying these values for percentile. And lastly, one last thing we'd like to do is execute the summary action to generate summary statistics for all the numeric columns in the iris table. And there is some detailed summary statistics for the iris CAS table. Next, we'll try out some data visualization. Since the tables that come back from the CAS server are essentially subclasses of Pandas data frames, you can pretty much do anything that works in data frames. So there is a method that we're going to use here called the plot method. And that's going to give me some very nice plot, nice visual here for the numeric variables in my table. Now we'll move on to data manipulation. If you recall earlier, I had pointed out that the maximum sepal width was greater than 4 centimeters. And we wanted to identify which ones they were. To identify this, we can use the head method on a subset of the CAS table. In this code, we are filtering out from the iris CAS table any sepal widths greater than 4 centimeters. So these are the rows of data where the sepal width is greater than 4 centimeters. We'll do some cleansing next. We've identified the 3 observations. Now we need to go ahead and do some cleansing. Some decisions need to be made about the outliers. Of course, there are many ways of dealing with outliers. You could, for example, either replace a value or you could completely remove the observation. For this record, what we'll do is temporarily replace the value of the reading score to a null value. And the replace CAS action is called the replace method on the CAS table. So you can replace any value of 4.4. We had one value of 4.4, and we're going to replace any value of 4.4 with the value of nan. Nan in Python indicates a Python missing value. We also have an in-place option. We'll set it to true, which replaces the value directly in the dataset. So that's done. This is the CAS column that we were trying to influence. Now we'd like to validate that no rows exist with a sepal width of greater than 4. So we'll request the head method, and we'll filter sepal width for any rows greater than 4 centimeters. And the only 2 rows that are returned are the other ones, which had a sepal width of 4.1 and another sepal width of 4.2. To terminate the CAS session, you'll just submit con.terminate. That brings us to the end of this tutorial. If you have any questions, feel free to reach out. Thanks for watching.